Okay, hi everyone. Welcome back to our statistics class notes. We are now on page 127 in section 8.2. This is the last page in section 8.2. We're discussing hypothesis testing. So let's do one more example and hopefully drive home what's going on again with this hypothesis testing idea. So according to the NCAA, the estimated graduation rate for Division I student athletes was about 87%. So that's telling you about, they think the estimated graduation rate for all Division I student athletes is about 87%. Suppose that in 2018, a random sample of 250 Division I student athletes is selected, and 210 are on track. So 210 of these 250 are on track to graduate. So the question we might be concerned with is, does this indicate that the proportion of all Division I student athletes who graduate is declining? Declining is a key word here. That means the alternative hypothesis will want to be less than. So we'll use the significance level of 5%. So our null hypothesis is that it's 87%. So P is equal to 0.87. The graduation rate for Division II student athletes is 0.87 based on what the NCAA is telling us. And we think that our sample might be giving us information that it's less than. So our alternative is that P is less than 0.87. Some value less than 0.87, which means that we think it's declining. The graduation rate is declining. Okay, so we're going to do, that's our hypothesize phase. Our prepare phase would be to set alpha, our level of significance, the chance of us being wrong by rejecting HO when it's actually true. Okay, now I also, in this preparation phase, we should also be checking the central limit theorem conditions. I kind of just blew by that on this example, but you should also check those central limit theorem conditions. Don't forget about those. And then we could do all this by hand, but we could also do it with StatCrunch. Okay, so I did these with StatCrunch, where you put in the number of successes is 210 and the number of observations is 250. Of course, that's how you get P hat. P hat is 210 over 250, which is 0.84. So our sample has 84% that are graduating. Now the question is that enough, right? Is that enough to say that we think the overall graduation rate for Division I, all Division I student athletes is declining? My hunch is not until we go through it, but let's go through it. So I got to compute the z-score, the test statistic, the z-stat, which is P hat minus P naught over the standard error, where the standard error is square root of P naught times 1 minus P naught over n. P naught's our null hypothesis, because that's what we're assuming is the truth. So that's what we use to compute the standard error at 0.0213, which then tells us our P hat has a z-score of minus 1.41. Means it's 1.41 standard deviations below the null hypothesis of 0.87. So 0.84 or 84% is 1.41 standard deviations below 87%. Is that enough? Well, if we get the p-value there, again, StatCrunch would give that to us, or we could use our StatCrunch normal calculator, where since it's a z-score, we use a mean of 0, standard deviation of 1. We get the probability that z is less or equal to that value, right? Our test statistic, or one more extreme, is 0.0792. So that is bigger than the alpha that we chose, so that means that we cannot reject HO. So let's see, how would we write that conclusion? Since the p-value, 0.0792, is greater than alpha, 0.05, we do not reject HO. Thus, there is insufficient or not enough statistical evidence to conclude the proportion of Division I student athletes who graduate is declining. Our sample, which said 84% were graduating, is not enough statistical information to say that the overall graduation rate of all Division I student athletes is declining. And here's the picture of what the p-value is, right? It's the probability of getting our test statistic when it's turned into a z-score is minus 1.41, or one more extreme. So the area to the left of that z-score. And again, the middle is 0 if you make it a z-score. The middle we assume to be 0.87. And here's our p hat, which is 0.84, which gives us a z-score of minus 1.41.